Alright, so the next part is on shifting the summation index. So this is actually the part that you will require on the next part. Okay, so this is a small parts that require to know before we go to the another bigger parts. Okay, shifting the index. Okay, so we know that the power series, it has the summation symbol, and from that we have the index. Okay, so the index of a summation in power series is a dummy index. So means that, let's say you have okay, like the previous one, we always have in terms of n, right? But then we can always change this symbol of n with another kind of symbol. It means the same. Okay, as long as we define it to be the same lah, it can be changed to another letter like k or I or another letter. Okay, shifting index of summation is important when we want to combine two different power series. So in order for us to combine two different power series, we need to always have the same power. Okay, so that's why we need to shift the index first if the power is different. Okay, for example, let us look at example 4. Okay, let us do example 4. Okay, example 4. Okay, what does it want? So, okay, show that this part is equals to this part. Okay, means that how can we shift the index from, okay, you look the difference between these two. This one has n equals to 0. This one n equals to 3. It starts from 0, and then this one starts from 3. And we have the subscript of n here. Okay, but then here we have the subscript of n minus 3. Okay, so how can we convert from this form to this form? But it is still equal, but it is still the same. It's just that the index is different. Okay, how can we do that? Okay, so initially the things that we want to convert is we have summation. Okay, we have cube n from 0 to infinity, n square n minus 2 en x to the power of n. So first thing first, we look at this. We have x to the power of 3 here, and then x to the power of n here. Okay, so then we need to combine this x first. We need to bring the x to the power of 3 inside the series. So this would give us, okay, we bring this inside. So this would give us n square n minus 2 en, and then we have x to the power of n, and then x to the power of 3. So it means the same as x to the power of n plus 3. Okay, and then okay, we look back at the things that we want to convert to. Okay, we want to convert to this one, right? Okay, so now the one that we have just now is x to the power of n plus 3, but then we want to convert to just x to the power of n. Okay, how to convert from n plus 3 to just n? So what we need to do, we need to set, okay, k is equals to n plus 3. Okay, because we want for the n to be just to the power of n. Okay, or in this case, I do as k lah, x to the power of k, but then we can change back to the x to the power of n because the index is a dummy index. Okay, so k is equals to n plus 3. So n is equals to k minus 3. Okay, so since here you look at this, our n start with 0. So what about k? So when n equals to 0, so then k is equals to 3. Okay, so now you can substitute this setup inside this power series. Okay, so what we have is Okay, n equals to 0. We want to convert in the form of k. So when n equals to 0, so k is equals to 3. Okay, and then for n square would become k minus 3 square. Okay, and then it with subscript of n minus 2 tertinggal. So n minus 2 would become k minus 3 minus 2. Okay, and then a subscript of n would become k minus 3. Okay, and then x to the power of n plus 3 would become x to the power of k. Okay, so now this is in terms of k. You can always change the symbol, the letter. So I change back to the n. So n equals to 3 infinity n minus 3 square. Then n minus 3 minus 2, this one becomes n minus 5. And then this become 8 n minus 3 x to the power of n. So you compare this one, we already get the converted version, like the one that we want to show lah. Not sure if I can copy that. No. Okay, tak apa. So you compare with the one that we need to show, then we get this form lah, sama lah. Okay, so this is the way on how you can shift the index. Okay, example 4. Okay, now we go to the next part. Okay, example 5. So it says that it has this series equals to 0. This implies that A naught A1 A2 is equals to 0 and AN is equals to this one for the case n greater than 3. So how can we show that this series implies this kind of explanation? Okay, let us do example 5. Kenapa tak boleh copy ya? Saya rasa macam boleh tapi tak apa. Okay, example 5. Okay, so look at example 5. Okay, if we look at this one, the first, I would say this is the first part of the series. This is the second part. Okay, you look at the first part, the n starts with 1. Okay, and then we have this x to the power of n minus 1. Okay, but then for the second part, n starts from 2 and we have the power of x is n plus 1. So the first thing that we need to do is we want to convert this x to become the power of just one number. Okay, let's say x to the power of k. Okay, the same goes for the second part of this series. Okay, to do that, I do this for the first part. Okay, so I need to set we need to set based on the power of the x. So I want to set k as equal to n minus 1 because I want for that n minus 1 to become just one letter, which is k. So I set k is equals to n minus 1. Okay, and then from this, for sure, you know n would becomes k plus 1. Okay, and then this part, n is starting from 1. So what about k? Okay, so when n equals to 1, then it gives the k equals to 0. Okay, this is for the first part of the series. Okay, so from this, we can shift the index. Okay, so therefore what we have is originally what we have is n from 1 to infinity, and then n a n minus 1 x to the power of n minus 1. So we shift the index, this one based on the things that we set. So this one would be n equals to 1 would becomes k equals to 0 to infinity, and then our n would become k plus 1, then a with subscript of n minus 1 which is k, and then x to the power of n minus 1 which is k. Okay, so we have this new form. Okay, this is for the first part of the series. Okay, we do for the second part. For the second part, what can be set? Okay, so we have the power of n plus 1. So we want to set it to be just the power of just k. So we set k equals to n plus 1. And then for sure, n would become k minus 1. So the n for the second part starts from n equals to 2. So what about k? So when n equals to 2, then k becomes equals to 3. Okay, because you substitute n equals to 2, 2 plus 1, k is 3. So now we shift the index. Okay, originally what we have is n from 2 to infinity, and then bn x to the power of n plus 1. Okay, this is the original one. We want to shift the index by using the things that we set up. So it becomes summation k equals to 3. Okay, because we know when n equals to 2, then k equals to 3. And then we have b with subscript of n, so means that we have subscript of k minus 1. And then x to the power of n plus 1, which is k. Okay, so this is the new form. Okay, now we rewrite back in the full form again. And we rewrite in terms of n. So you can just substitute from k to n directly lah. Okay, so what we have, okay, this part plus this part equals to 0. Based on the things that is given to us lah. So this one, okay, this first part would become n from 0 to infinity. K plus 1 becomes n plus 1. I just change from from k to n. I just change the symbol. So n plus 1 a n x to the power of n, and then plus n equals to 3 infinity b n plus 1 x to the power of n equals to 0. So we can try to solve this one, equating it become 0, because now we have the power of n is the same. Okay. Okay, now now look at this. The first part of the series, n starts from 0. But the second part, n starts from 3. So now what we can do, we try to combine these two series into just one summation. So to combine into just one summation, we can use the summation that starts from 3. So meaning that for the case of the first part, for the n starts from 0, we can separate first. For the case of n equals to 0, n equals to 1, n equals to 2. And then n from n to infinity, we can combine with the series, the second part of the series, n start from 3 to infinity. So what we can do, we keluarkan dulu for the case n0, n1, and n2. So we can separate that first. Okay, so when n is 0, you would get 0 plus 1 multiply with a node x to the power of 0. You would get it becomes to a node. Okay, when n equals to 1, okay, you would get 2a1 x1. Okay, when the n equals to 3, you would get 3a2 x2. For n equals to 0, 1, 2. Okay, 3 no need, because we want to combine with the series at n starts from 3. So we have only 0, 1, and 2. Okay, and then we can plus with the summation n from 3 to infinity, n plus 1 a n x to the power of n, and then plus summation. I just write it full first, in full form first, equals to 0. Okay, now we can combine this two series because it starts from 3 to infinity. And what else you can combine? You can combine x to the power of n with this one, right? So we can rewrite back a naught plus 2e1x plus 3e2x square plus summation from n3 to infinity. Okay, I put a bracket, kn plus 1 en plus bn minus 1, close a bracket. Since both have x to the power of n, the same thing, so I can write it that way. Okay, so this one equals to 0. Okay, so now recall back about the theorem. Okay, I show you the theorem that we have go through previously. Okay, sekejap kat mana? Okay, this theorem. Okay, if you have this power series equals to 0 for all x in some open interval, then each coefficient en is equals to 0. So we can equate this en equals to 0. Okay, not this part. Okay, so based on that theorem, we can apply to this example. Okay, so since this one, it is equals to 0, right? So means that this part en, a1, a2, a naught, a1, a2, and this is also the part of en actually, we can equate that equals to 0. So we can say that a naught equals to e1 equals to e2 is equals to 0. Okay, so you look back at the example, it says that, so this implies that a naught, a1, a2 equals to 0. So we already get that. Okay, second part, we have this part should also be equated to 0, because to get it 0, then that part should be 0. So what we have is n plus 1 en plus bn minus 1 equals to 0. So you can rewrite this, okay, tertinggal bracket, n plus 1. Okay, we can rewrite this in terms of, we want the en to be the leading. So if en, then it equals to negative bn minus 1 divided by n plus 1. Okay, so you have this kind of correlation, and this one is equals to 0. So this is the same thing as what it has been said lah. So this implies that this one equals to 0, and you would get that en is equals to this one. But please note that this is for the case when n is greater equals to 3. Okay, for n greater equals to 3, because this series starts from 3. Okay, that is the condition. Okay, and then exercise 2. Okay, this is, I think this is based on the exercise. Okay, but then you can try to do this. This is also almost the same as the first example on shifting the index. Okay, try to show for this one. How can be this one becomes this one by shifting the index? Okay, you can try this by your own.